Hello everyone, welcome back. Today's video is going to be a very special one because as you have seen from the title also, we are going to do JEE mains paper discussion. This was the paper that was held on 5th September 2020 in the evening shift. Okay, now the questions are memory based because NT has not published the question paper yet. So there may be some error in the data, but still we will discuss all the concepts that are pertaining to a question. Okay, now if you want more of such paper discussions, don't forget to subscribe to this channel and press that bell icon. And if you like the content, if you like the presentation, please let me know by pressing that like button. Okay, and also let me know the feedback, exact feedback on the in the comment section, and please share it with your friends. So without any further ado, let's start. So the first question that we have here is from Kinematics. So here they say a velocity time graph of a particle is shown in the figure. Find the displacement of the particle. So from velocity time graph, how to find displacement or distance? You just have to find the area under the curve. Because we know that velocity is equal to dx by dt. So if you rearrange, dx will be equal to v dt. And if you integrate on both the sides, you will get displacement. Okay, so displacement is equal to integral v dt, and integral v dt is nothing but the area under the curve. Okay, so but there is a difference in finding displacement and distance. If you're finding distance, you have to take the magnitude of the area. You don't have to consider this negative sign. If there is a negative sign, you don't have to consider. But if you're finding displacement, as in this question, this will be positive area and this will be negative area. So you have to add according to the sign. You have to take care of the signs. Okay, I'll keep my video here. Now I've already written the answers so that we don't have to waste time. So you see, displacement is equal to area under the graph, and area is area of this triangle. This is number 1, this is number 2, this is number 3, and this is number 4. But the problem is, for finding the number 4, this point, the time at this point is not known. The time at which the velocity becomes 0 is not known. So that you have to find using similar triangles. So that's what I've done here. Using similar triangles concept, I have found the position. That means the time. Okay. So I've taken this much time as x. Okay. And according to the similar triangle, we know 4 divided by x will be equal to 2 divided by this much. But actually we know that from 3 to 5 it is 2 seconds. So this will be 2 minus x. So that's what I've written. X divided by 4 is equal to 2 minus x divided by 2. Okay. So if I rearrange, I'll get x is equal to 4 by 3 seconds. So x, this distance is, this distance in the graph is 4 by 3 seconds. So we have found that. Now let's go to the area. First area, that is area of the triangle. Sorry. So area of the triangle will be half into base into altitude. So base is 1 and altitude is 4. So half into base into altitude is half into 1 into 4. Then you have rectangle over here, that will be 2 into 4 because this is 4. Okay. So it will be 2 into 4. That's done. Now the area of this triangle, it will be half into base into altitude. Now base is 1. Base is 4 by 3. We have already found it. Base is 4 by 3 and the altitude is 4. So it will be half into 4 by 3 into 4. That's also done. Now why do you see there is a minus over here? Because we are finding the displacement. If we were finding the distance, then this quantity should be added. It would be plus there. Anyway, now the area of this triangle will be half into base into altitude. Now base is not 2 minus x by 3. 2 minus x. But you have to add 1 to it. So that's why you see 1 plus 2 by 3. Because 2 minus x will be 2 by 3. 2 minus 4 by 3 will be 6 minus 4 by 3, which is 2 by 3. So 2 by 3 plus 1 is the base and the altitude is 2. Altitude is 2. Actually, this negative sign is coming because here you are taking minus 2 and that minus is coming over there. Now if you add, this is 2. Okay. This is 8. So 2, 8. And this will be 2 and 4 will get cancelled. This will be 8 by 3. And here you will get, if you take LCM, this will be 3 plus 2, 5, 5 by 3. and this 2 and this 2 will get cancelled. So you will get 5 by 3, and finally the answer will be 11 meters. So it wasn't a very difficult question. This was pretty simple. Let's go for the next question. In the next question, they are saying a body of mass 2 kg at rest is supplied constant power. So this is what you have to underline: constant power, 1 joules per second or 1 watt. The distance traveled by the body after 9 seconds is. So you have to find the distance. So let's start from what we know. We know that the power is 1 watt. Power is 1 watt. So, and it is constant. So power is 1 watt and it is constant. Okay. Now we have a relation that power is equal to work done divided by time. It is the rate of doing work. So power is equal to rate of doing work, which is work done divided by time. So work done is equal to power into time. Okay, and we can write directly like this because it's a constant power. If it was variable power, then we would have had to write it this way. Okay, you have to integrate with respect to time. But anyway, it's a constant power, so power can be taken outside, and integral dt is nothing but t, so p into t. But power is given as 1 joule per second or 1 watt. I've substituted the value here. So the work done will be T joules. This J stands for joules. So T joules. Now from work energy theorem, we know that work done, then total work done on a body is equal to change in kinetic energy. Why are we doing all these things? Because we have we have an aim. Our aim is to find the distance. So if we find velocity, we know that velocity can be written as dx by dt, and accordingly we can find the distance. So that's our aim. Now work done is equal to change in kinetic energy. Now why have I written half mv square and not half mv square minus half mu square? Final kinetic energy minus initial kinetic energy. Because initial kinetic energy was 0, it started from rest. So it is half mv square is equal to t. If I rearrange, I can write it as v is equal to root of 2t by m. Because this 2 will go in the numerator here and m will go in the denominator. And that's why we will get v is equal to root of 2t by m. Now we know that the mass is 2 kg. So if I substitute, 2 and 2 will get cancelled. So we will be left with v is equal to root t. Now v can be written as dx by dt, or in this case I have taken L. So dl by dt, rate of change of position. So that is dl by dt. If I rearrange, I can write it as dl is equal to root t into dt. And if I integrate, I'll get the total distance. So total distance traveled is L here. So L is equal to integral 0 to t root t dt. Now we know that integral of x raised to n dx is equal to x raised to n plus 1 divided by n plus 1. Here we have t raised to 1 by 2. So integral will be t raised to 1 by 2 plus 1, which is 3 by 2, divided by 1 by 2 plus 1, which is 3 by 2. So that's what I've written. Distance, total distance traveled is t raised to 3 by 2 divided by 3 by 2. And this 3 by 2, when it goes to the numerator, it will become 2 by 3. And finally, the distance traveled will be 2 by 3 into 9 raised to 3 by 2. But 9 is what? 9 is 3 square. So 3 square and this root will get cancelled. So it will be 3 raised to 3. 3 raised to 3 is 27. 27 into 2 by 3 will be giving you 18 meters. So that's a very simple question. These two questions were very simple. Now let's go to the next question. Now this is from dual nature. Okay, dual nature of particles. So here they are talking about photoelectric effect. You are sending there is a light incident on a metal surface. Actually two light sources are there, and two photons are striking the metal surface, and because of the energy being absorbed, electrons are emitted. Now the minimum energy required for the electrons to be emitted is the work function, and excess, how much energy in excess you are giving, that will be given for the kinetic energy of the electron, or that will be coming out as the kinetic energy of the electron. Okay, so now there are two photons. Now when they strike, what will be the energy? So you can give energy is equal to work function plus kinetic energy, maximum kinetic energy of the photoelectron. And for each of the cases, we can write E1 is equal to 5 plus KE1, and E2 is equal to 5 plus KE2. We can rearrange KE1, that is the kinetic energy in the first case, is equal to E1 which is the energy given by energy of the light photon, E1 minus phi, where phi is the work function. Okay, so again we can substitute kinetic energy is equal to half mv square, and we can write two equations based on both the light source. Now we can take the ratio of these two equations. Will half m and half m will get cancelled. You will get v1 divided by v2 whole square is equal to e1 minus phi divided by e2 minus phi. Now we can substitute. v1 by v2 is given as 2. So v1 by v2 whole square will be 4. 4 is equal to 4 electron volt. Now I am not changing the electron volt to joules because I will get the answer in electron volts. There is no issue in that. If the options are in joules, you will have to convert it. You will have to multiply it with 1.6 into 10 raised to minus 19. Anyway, so 4 is equal to 4 minus 5 divided by 2.5 minus 5. If I rearrange this, I'll get it. Now you can also apply component or dividendo if you want. Okay, component or dividendo, you remember, if you have a by b is equal to c by d, then you can also write a plus b divided by a minus b is equal to c plus d divided by c minus d. It will also give you the answer very quickly. It's up to you. If you want to cross multiply, you can do that. Otherwise, you can use component or dividendo. Anyway, the final answer will be work function is equal to 2 electron volt. I hope it is clear. Let's proceed to the next question. Okay, now this is a question from kinetic theory of matter. An ideal diatomic gas is taken through an adiabatic process. Actually, it's from thermodynamics. An adiabatic process in which the density increases to 32 times. If pressure increases to n times, find n. So since the density is increasing to 32 times, the volume will decrease by 32 times, because density is inversely proportional to volume. We know density is equal to mass by volume, and here mass has not changed. New atoms have not come into picture. So it's the same mass. So mass has not changed. So density is 32 times, means volume will become 1 by 32 times. And we know it's an adiabatic process. For adiabatic process, we know that PV raised to gamma is constant. It's a very straightforward question. Okay, so you can write P initial V initial raised to gamma is equal to P final V final raised to gamma. I can rearrange. So final pressure is equal to this term into Pi. But they said if the final pressure increases to n times, find n. So what is this? This term itself is n. So that's why I've written n is equal to Vi by Vf whole raised to gamma. But what is Vi by Vf from this? From this, Vi by Vf is 32. If I rearrange, I can get Vi divided by Vf is equal to 32. So that 32 has been substituted here. And gamma, it's a diatomic gas. For diatomic gas, you have to remember gamma is equal to 7 by 5. So substitute 7 by 5. Now 32 is equal to 2 raised to 5. So this 5 and this 5 will get cancelled. You will be left with n is equal to 2 raised to 7. So 2 raised to 7 is nothing but 128. So pressure will become 128 times the initial pressure. I hope it is clear. Let's go to the next question. A dielectric having dielectric constant K is equal to 4 is filled in a capacitor having plate length L and width B. Now length of the capacitor is increased by L1, for which energy stored becomes half of its initial value. L1 should be. Okay. Now you have a capacitor. This is a capacitor. Okay. Inside you have filled with dielectric of dielectric constant 4. So it will have certain capacitance, which is given by C is equal to K E naught into area divided by the gap. Now gap is given as D. The length is given as L, and the breadth, the width they are talking about is actually perpendicular to the plane of the paper. It's inside. So area will be length into breadth. So if I draw the side view will be something like this. This is the side view, and this will be breadth and this will be length. I hope it is clear. Okay, there will be a connection here. Okay, so that was that. Now they said that the energy stored becomes half of its initial value when the length of the plate is increased. Now length is increased. Okay, length is increased by L1, not to L1. There is a difference in that. So that means already it was L. Now you increase by L1. That means the total length has become L plus L1. Okay, so now let's take this condition. Energy stored becomes halved. Energy stored in a capacitor is half Q square by C. Okay, and here it's not connected. It's not mentioned in the question, but we assume that it's not connected to any battery because they did not tell about any voltage or anything. So we understand that the charge in the capacitor is not going to change. If it was connected to the battery, it would be different. The charge would change. We have to use the other equation, which is half CV square. No, yeah, half CV square. Okay, so yes, so here we are using half Q square by C because Q is constant. So Q is going to get cancelled on both the sides, and you get final capacitance is equal to 2 times initial capacitance. Okay, it's all because we got final energy is equal to half initial energy. So this is an important relation that we want here. Now from this we can write. Now we already discussed that the capacitance in the beginning. Let's talk about the initial capacitance. Initial capacitance is K into epsilon naught into area divided by gap. Area is length into breadth. So I've substituted that. Now 2 is already here. Now the final capacitance. You see that these two are as if they are in parallel. It's as if they are in parallel. It's like this. One without the dielectric and the bottom part is with the dielectric. So you know that equivalent capacitance in case of parallel capacitors are C equivalent is equal to C1 plus C2, and that's what we have done, C1 plus C2. Okay, what is C1? It's without the gap, so epsilon naught into area, but area is length into breadth. Only L1 area, L1 length you have to take because that's where the dielectric is not present. So E1 epsilon naught area divided by D. So epsilon naught L1 D, L1 into B divided by D, that is the capacitance here. And now the capacitance below will be K epsilon naught. See, because it's a dielectric constant, dielectric constant K is kept inside. So it will be K epsilon naught into area, which will be L into B divided by D. Now if you rearrange them, you will get finally L1 is equal to 4L. Again, not a very difficult question. It's all straightforward. Okay, now this was a question from optics, and you see that there is a prism. So this is from the prism of refractive index 1.5, and the prism angle is given. It's a very small angle. This is a thing that you have to note. The angle is very small, so you can use the simplified equation for finding the minimum deviation. You don't have to use the bigger equation. The simplified equation, which is delta minimum is equal to mu minus 1 into A, can be used. And it's a very simple question. Direct substitution, mu is 1.5 minus 1 into 2 degree, and the minimum deviation is 1 degree with that. Okay, very simple. This is the deviation, and it will be minimum if it applies this condition. Okay, now next question is from motional EMF. It's also very straightforward. Okay, you have a conductor of length L. When it is moved in a magnetic field B, we know that the EMF induced will be BLV. So EMF induced is BLV. They have given the resistance and they are asking to find the current. Come on, 10th standard students can find this. If EMF is known, how to find current? Current is equal to EMF divided by R. So that's what we have written here. It's a very straightforward question. Very astonishing that this is asked in JEE. Okay, so this is the circuit, equivalent circuit. Okay, let's go to the next question. So now this is okay question. So you have a capacitor. You have 3 capacitors here. You have to find the charge on 5 microfarad capacitor. Okay, so what you can do is you can conserve the charge here. First of all, we know that this is positive terminal, so positive terminal is connected to this capacitor. So we'll write plus Q1 here and minus Q1 here. Similarly, this positive terminal is connected here, so I'll write plus Q2 here and minus Q2 here. And again, now these two are negative charges, so negative charges has gone here. So obviously to balance it, this should be positive charge, so plus q3, and here it should be minus q3. Now conservation of charge, that means if you take a system like this as shown in the green dotted line, you know that the total charge should be 0, because initially this is a conductor, right? This is a conductor and connected by many connecting wires. So they were neutral in the beginning, they will be neutral in the end also, because charges cannot be produced. Charges are neither produced nor destroyed. So according to the conservation of charge, we know that minus q1 minus q2 plus q3 should be equal to 0. That's the very first equation. Now, what is q1, q2, q3? We have a relation q is equal to CV, where C is the capacitance and V is the positive potential difference. V plus minus V minus. The positive plates potential minus negative plates potential. So it will be 6 minus x. Oh, by the way, how did we get this 6 and all? If we take, see, one of the points we'll take as potential is 0. Just like we take in mechanics. In mechanics, we take gravitational potential energy is 0 at the ground, usually. Okay, that's the datum. So just like that, we have taken this point as the datum. So this is the point where 0 volt is present. So now if you go across this cell, the potential is increasing by 6, because you are going from negative to the positive terminal. So the potential here will become 6. Now there is no resistor here, so the potential difference will not be there, or potential drop will not be there. So here also the potential will be 6. If you apply the same logic on the right side, again you will get 6 here and 6 here. But here we don't know the potential, so I have marked it as x. So what is the potential difference between for the 2 microfarad? It will be 6 minus x. And what is the potential difference for 4 microfarad? It will again be 6 minus x. What will be the potential difference for 5 microfarad? It will be x minus 0. See, the potential difference is x minus 0. So that's what I have done. This is C into V. V is 6 minus x. And why minus is there? Already there is a minus in the equation. Again minus is here. And 4 into 6 minus x plus 5 into x minus 0, which is x. Okay? Hope it's clear. Okay. Any doubts you have, you can let me know in the comment section. Now let's proceed. So if I open the brackets, I can simplify, and finally I'll find x is equal to 36 divided by 11 volts. And we want to find the charge, so we can apply this equation again. Q is equal to CV. So charge stored by 5 microfarad will be C, which is 5, into x minus 0, which is x, which we already found, and that will come out to be 180 divided by 11 microcoulomb. Now don't forget this micro, because we have not converted the microfarad into farad, so the charges will be in microcoulombs. Hope it is clear. Let's proceed to the next question. Okay, this is based on variable mass system. Okay, mechanics. So it's a rocket. So when rocket is propelled upwards, what happens is, see, there will be a force. See, gases are coming out. So we know from Newton's second law that any force is proportional to or equal to, because the proportionality constant is 1, dp by dt, where dp by dt means what? Rate of change of momentum. Now in this case, the velocity with which the gas is coming out is constant. It is u. The velocity with which the gas is coming out is u. So we can write mu dmu divided by dt, and that will become u into dm by dt. Why? Usually we have been writing m into du by dt, right? Which is ma. But why do we write u into dm by dt? Because it's a variable mass system. Okay, the gases are coming out. The rate at which the mass of gas is coming out is dm by dt, and the velocity with which it is coming is constant, which is u. So this is the force applied by the rocket on the gases. According to Newton's third law, every action has equal and opposite reaction. So what will be the upthrust, or the thrust provided by the gas, exhaust gas, on the rocket? It will be same, right? It will be just same in magnitude but opposite direction. That's why we have written F thrust is in upward direction. When the rocket is being pushed upward by the exhaust gases. Is that clear? If it was near the Earth's surface, then there will be an mg downward, but here it is said it is in free space. It's moving in free space, so there is no mg downward. So this is itself the net force. The net force on the rocket is thrust. There is only one force. So thrust is equal to net force, and net force is equal to ma according to Newton's second law. So you said this, it is equal to u into dm by dt. That's for the gas. Okay, but for any object which is accelerating upward, we can use F is equal to ma, because the mass of the rocket at that instant is constant, and you are finding the instantaneous acceleration. So this is mass, instantaneous mass into instantaneous acceleration. Is that clear? See, m is the instantaneous mass. So this is applied for an instant. So now we can substitute u into dm by dt here, which we already found. Is equal to m into a. You can rearrange a is equal to u by m into dm by dt, but dm by dt is given here. So this is a very straightforward question, because you just have to substitute that. You don't have to integrate and find something else. Okay, usually when students see such kind of data, they would assume that this requires integration and they'll leave it. Here there is no integration required. It's a direct substitution problem. Hope it's clear. Let's go to the next question. Okay, there is a radioactive nucleus A, which disintegrates into B with half-life 10 seconds. A also converts into C with half-life 100 seconds. So you have to find the half-life of A for both emission. Dekho. So that means the A, sometimes it gets converted to B, sometimes it gets converted to C. So that means 100 atoms of A is there. Then maybe 10 atoms will convert to C, and 90 atoms will convert to B. That's just an example. Okay, now so that means every second there will be some radiations produced, or some amount of atoms decaying, which is called rate of decay, and rate of decay is given by dn by dt. So dn by dt is nothing but the sum of the decay rate of to both B as well as C. So this is the rate at which B is produced. This is the rate at which C is produced. Okay. So the total rate is equal to the rate at which B is produced and the rate at which C is produced. You can think of it like this. You have a container carrying water. There are two holes. So what is the rate at which water is coming out? It is the rate at which water is coming out through one hole plus the rate at which water is coming out through the other hole. Okay. So that's what we have written here. dn by dt is equal to dn by dt for 1 and plus dn by dt for 2. But we have a very standard equation. dn by dt is equal to lambda minus lambda n. Okay. So we have substituted that, minus lambda 1 into n minus lambda 2 into n. Why haven't I written n1 and n2? Here n is the total number of atoms present. So at any instant, the total number of atoms of A will be same, whether you're talking about formation of B or formation of C. So that's why n is written over here. So it will be minus lambda 1 into n minus lambda 2 into n. If you take minus n common, it will be minus lambda 1 plus lambda 2 into n. And this lambda 1 plus lambda 2 can be written as lambda effective. You want to find the combined time period, half-life. Okay, so this lambda 1 plus lambda 2 can be written as minus lambda effective. So dn by dt is equal to minus lambda effective into n. So from this we get lambda effective is equal to lambda 1 plus lambda 2. And we know the equation for this is the decay constant lambda. So lambda is given by ln n, logarithm, natural log of n, natural log of 2 divided by time, half-life. Oh, I forgot to write 2 here. It is ln 2. Okay, ln 2 divided by half-life. So here ln 2 divided by half-life of the combined for both the emission is equal to ln 2 divided by half-life of the first emission, that is A, production of B, and here the half-life of C. So ln 2 will get cancelled everywhere, and you will get, if you see this, it is 1 by T effective is equal to 1 by T1 plus 1 by T2, and if you rearrange, you will get T effective is equal to T1 into T2 divided by T1 plus T2. If you substitute, you will get approximately 9 seconds. Hope it is clear. Now, this was a question from gravitation. there are two bodies A and B of same mass. A is placed near the equator of the earth and B is placed at a height h above the pole of the earth. If both the bodies weigh equally, find h in terms of radius r of earth, angular speed omega of earth, and g acceleration due to gravity close to earth. Okay, so again see, they told that one of the object is placed on the equator. This is the equator. Okay, this circle is the equator, and one of the other body is placed near the pole. This is the pole. Okay, so at a height h. But they said that first of all the mass is same. So mass of the object here is m. This is also m. I have written it as mp and me to show that it is the mass kept at pole or kept at equator. So mass is same, and again they have given another data, which is weight is also same. So weight of the particle kept at pole is equal to weight of the particle kept at equator, and it is equal to mg. So mass gets cancelled because masses are same. So gp is equal to ge, which means the acceleration due to gravity at this point is equal to acceleration due to gravity here. But since the earth is rotating about this axis, this is the axis of rotation. So since earth is rotating about the axis, the force here will be mg downward and m omega square r outward. It's a centrifugal force, pseudo force we have applied there. So net force will be mg minus m omega square r, or g effective. The effective acceleration there will be g minus omega square r. Okay, because m gets cancelled everywhere. And so here and again here at the pole, the acceleration due to gravity is g into 1 minus 2h by r. Why can we take this equation? This is an approximate equation, if you remember it right. Why are we able to take it? Because you are talking about it's very close to earth. Okay, and it's common sense, if the acceleration due to gravity has to be same, it should be close to earth. So that's why we can use this equation. So g into 1 minus 2h by r is equal to g minus omega square r. If I multiply, the g will get cancelled. Finally, you will be left with h is equal to omega square r square by 2g. Hope it is clear. Now next question. This was based on system of particles and rotational motion. Okay, they have combined it with the oscillation also. So you have two rings. Actually, this is if you note it down, this is from compound pendulum. Compound pendulum means if you have some mass, some random mass here, and you are hinging here, and it is oscillating about this hinge. Okay, then the equation for the time period is like this. You remember, for the equation for time period of simple pendulum is 2 pi into root of L by G. But here it will be 2 pi into root of I by mg into xcm. Xcm means the position or the distance of the center of mass of the compound pendulum from the hinge. So it will be nothing but this. This will be xcm. Center of mass, the distance of the center of mass from the hinge. Okay. But we see that the center of mass, the distance of the center of mass is same for both the system, whether it's ring 1 or ring 2. So that's why this does not matter. So we can clearly say time period is directly proportional to root I only, because all these are constants. 2 pi is constant, mass is constant because mass is same, and g, acceleration due to gravity, is constant, and xcm is same. It is both equal to r. So T1 by T2 is to be found out. T1 by T2 is nothing but root of I1 by I2. But I1 and I2 you have to find separately. So let's find I1. I1 we can find. I1 will be equal to, you see, we can apply parallel axis theorem. So parallel axis theorem says I is equal to moment of inertia about any axis is equal to moment of inertia about the center of mass, axis passing through the center of mass, plus m into distance square. The distance between the two axes is r. So m into r square, you have to add with moment of inertia about the center of mass. And moment of inertia about the center of mass, you don't know, right? The moment of inertia about the center of mass you can find using perpendicular axis theorem. All these you might have learned. The axis, if it is perpendicular, you have, it is mr square if it's a ring, and if it is perpendicular to that axis, it will be mr square by 2. If you take symmetry, there are two axes, and accordingly you can find. Anyway, so it is mr square by 2 plus mr square, which will give you 3 by 2 mr square, and again I2 will be just mr square plus mr square, so it will be 2 mr square. Just substitute here, you will get the answer. T1 by T2 is clearly very easily found. Let's go for the next question. Next question is, again this is from rotational motion, system of particles and rotational motion. So here you have a rod of mass 0.5, one second, a rod of mass 0.5 0.9 kg and length 1 meter is hinged at the point O. This is the point O. A bullet of mass 0.1 kg moving with velocity 80 meter per second strikes the rod at its bottommost point and sticks. Just after the collision, the combined system starts rotating about the hinge point O with an angular velocity omega. You have to find omega. Now here there will be a force applied by m1 on this rod, but if you consider both the masses as a system, then there will be no net torque. The net torque about O is 0, and you know that when net external torque is 0, we can say momentum is conserved, angular momentum is conserved. So initial angular momentum is equal to final angular momentum. So initial means before striking. So before striking, this is the linear momentum of the particle, and multiplied by the perpendicular distance will give you angular momentum. Angular momentum is mvr, linear momentum into perpendicular distance. So that's what I've written, linear momentum into perpendicular distance, which is L. That was initial momentum, initial angular momentum. Now final angular momentum, you have to write I omega. So L is equal to I omega, because we have to find the angular momentum, I omega. So it will be what is the moment of inertia of a particle at a distance L? It will be ml square. So ml square is the moment of inertia because of the bullet, and moment of inertia because of the rod will be 1 by 3 ml square, because it's the hinged at the end. If it was hinged at the center, then it will be ml square by 12, but it is hinged at the end point, so it will be ml square by 3. So this is the total moment of inertia into angular velocity. It's just now rearrangement. You have to rearrange and find omega, which will be equal to 20 radians per second. Next question, it was based on units and dimensions. It's a very simple question. We know that x 1 by root of mu naught into epsilon naught. It's nothing but c. It is the speed of light. Again, y is equal to e by b. Again, it's c. So the units of x and y are same. Actually, options there were like x and y are same, y and z are same, x and z are same, and something of that kind of thing. Again, there is an ambiguity on this data. If it is 1 by rc is the time constant. RC is the time constant, and so it will have a unit of 1 by second or hertz. But in some students say that this was L, which was length. If it is length, it will have meter per second, and so we can say the units of all the three quantities were same. So it depends on the data. If it was L by RC, it will be the same for all. If it was 1 by RC, only X and Y are same. Chalo badhiya. Now this was a bit of good question. You have 10 charges plus q and minus q in alternate positions placed uniformly in a circular ring. So you see, one second. So you see, plus q if it is placed here, then minus q, plus q, minus q. What will be the angle between each of these lines? Because it's 360 degree, the total angle is 360 degree, and you are dividing it by 10. So each will be 36 degree. 36 degree. So 36, 36, and so on. Now potential, you have to compare the potential. The options were like V is equal to 0, E is not equal to 0, V equal to 0, E equal to 0, E equal to 0, V not equal to 0, and that kind of thing. Anyway, so we just find V and E. Potential, okay, I'll keep it. Where should I keep myself? Okay, here. So the potential is the sum of all this, and potential is a scalar quantity. Okay, electric potential is a scalar quantity. So you see that it's all in pairs, plus q and minus q are in pairs, and it's at equidistance from the center. You have to find the potential at the center. So clearly it will be 0. There is no doubt in that. You can just check it, because this one will cancel the next one, and the next one will cancel the next one, and so on. It will be in pairs, so it will be 0. But electric field, many students will think that electric field, or potential is a scalar, so it becomes 0, but electric field is a vector, so it will not be 0. So that's the logic that many students right away put, but that's not the case. E also is equal to 0, because you see, the potential, the electric field will get added up. Due to plus q it will be this way, due to minus q also this will be this way, so it will add up to give this one. Can you see this one? And similarly, this plus q and this minus q will give here, this plus q and this minus q will give here, this plus q and this minus q will be giving here. And see, it is symmetric. If it is symmetric, the vector sum will be 0. You want to check on that? I'll tell you an idea to understand that. Suppose the electric field was E. Okay, now if I rotate this system by 72 degree, I'll get the same system, right? If I rotate this system by 72 degree, I'll get the same system. But electric field would have rotated by 72 degree. And how can the electric field will be same in both the cases? It will be same only if electric field is 0. Did you understand the logic? Yeah. For this, let's say electric field is like this. This is the direction in which electric field is present. But now if you rotate the system by 72 degree, you will get the same system. So the electric field should be here, but electric field would have rotated by 72 degree. So how can these two electric fields be same? It cannot be same. It can be same only if electric field is 0. Done. Let's go to the next question. No. Okay, so you have an iron core solenoid, okay, of turn density 10 turns per centimeter, and volume is 10 raised to minus 3 meter cube. It carries a current of 0.5 ampere, and relative permeability of iron core, its iron core, is mu r is equal to 1000. The magnetic moment of the solenoid you have to find. Now here it's a little bit good question. You know that the intensity of magnetization inside a solenoid is given by the magnetic moment divided by volume. It is the magnetic moment developed per unit volume. So with that, we can rearrange and we can write the magnetic moment developed is equal to intensity of magnetization into volume. But what is intensity of magnetization? That also you can get. We know that the total magnetic field inside the solenoid will be the magnetic field provided externally. This is the magnetic field provided by the electric current, and this is the magnetization happening inside the core, because the domains will rearrange in such a way that it will also produce a magnetic field. So these two magnetic fields will be combining to give you the net magnetic field, the total magnetic field, or magnetic induction it's called. So B is equal to mu naught H plus mu naught M. We have this relation. This is magnetizing intensity, and this is the intensity of magnetization. So if you take mu naught if I want to find M, so I will rearrange in such a way that M is separated. Now M is equal to B divided by mu naught minus H. But B also has a relation. B is equal to mu into H, where mu is the permeability of the medium. So we can take H common. H is equal if you take common, you will get mu divided by mu naught minus 1. But mu divided by mu naught is nothing but relative permeability, which is given here. Now this, if you substitute here, you will get small m, which is the magnetic moment, equal to mu r minus 1 into volume, which is here, into H, where H is n into I. So now you can directly substitute 1000 minus 1 into volume is 10 raised to minus 3 meter cube, and turns per centimeter was 10. This was 10 turns per centimeter. If you want to find turns per meter, it will be 10 raised to 3, and multiplied by 0.5 is the correct. So if you multiply everything, you will get approximately 4 you will get 495.99.5, but you can approximate it as 500. Okay, next question. A car is moving towards a fixed wall. It blows horn of frequency 440 hertz. The frequency of reflected sound observed by the driver is 480 hertz. Then find the speed of the car in kilometer per hour. Now here this is based on Doppler effect. Now the sound wave produced by this car gets reflected by the wall, so it can be assumed as being reflected by a mirror. So that means this is the image of the car. So it seems as the sound is coming from this side. So this will become the source and this will become the observer. Okay, this is a very important concept here. So if in any question, if the sound wave is reflected, then you can consider an image and the sound being produced by the image. Okay, so this is the, now we can see that the source is moving with the velocity vc towards the observer, and observer is moving with the velocity vc towards the source. So we know that when the source and the relative velocities, relative motion is towards each other, then the frequency should increase. So there will be a plus in the numerator and minus in the denominator. Remember that. Now it's just direct substitution. 480 is the observed frequency. This is the actual frequency, into 350 is the speed of the sound, plus speed of the source, plus speed of the observer, divided by speed of the sound minus speed of the source. This will give you, if you rearrange, it will give you Vc is equal to 350 by 23 meter per second, but we want it in kilometer per hour. So multiply by 18 by 5. 18 by 5 is multiplied to convert it to kilometer per hour, and you get it like this. Again, you remember I used the concept of componendo dividendo in previous question. That's the same thing I have used here. To convert this to this, I have used componendo dividendo. Okay. So next question. There are two rods of length L1 and L2, and coefficient of linear expansion are alpha 1 and alpha 2 respectively. Find the equivalent coefficient of thermal expansion for their combination in series. So you have rod 1 and rod 2 combined in series. They are end to end connected. Now we see that this is the expansion due to the temperature change, delta 1 and delta 2. So what will be the total change in length? Total change in length will be the sum of these two, delta 1, delta L1 plus delta L2. Or we can say the total length has become how much? L1 dash. This has become L1 dash, and this has become L2 dash. So what is the total length, final length? It will be L equivalent dash is equal to L1 dash plus L2 dash, and we know that L1 dash is equal to L1 into 1 plus alpha 1 into delta T. This is a standard equation. This is the equation for the final length after thermal expansion. And if you add, now it's just rearrangement. If you add and rearrange, you will see that some of these quantities gets cancelled, and finally alpha equivalent will be equal to alpha 1 L1 plus alpha 2 L2 divided by L1 plus L2. Okay, and this is the final question that we have here. Some questions I did not get, so this is the last question that I have with me. A ball is dropped from a height h. It falls on the liquid surface. Its velocity does not change when it enters in the liquid. Find the height h in terms of radius of the ball, density of the liquid and density of the ball, and coefficient of viscosity and acceleration due to gravity. Now let's say this ball was dropped from a height h. It was dropped from a height h. Now when it falls, it will reach a velocity which is equal to root 2 gh. It's from kinematics. By applying v square is equal to u square plus 2as, you will get it. So v is equal to root 2 gh, but that velocity will be equal to the terminal velocity inside the liquid. Why? Because the velocity does not change. We know that when an object is moving in a medium, if its velocity is not changing, that means it's clearly the terminal velocity, and terminal velocity is attained, velocity is not changing, that means the net force is zero. So you can see what all forces are acting on this body. Mg acting downward, then buoyancy force or buoyant force are acting upward, and this is the drag force or viscous force. Okay, now we have net force is equal to 0, which clearly gives us Fv plus Fb is equal to mg, and we know the equation from Stokes law. Fv is equal to 6 pi eta rv, where r is the radius of the ball and v is the velocity with which the ball is falling, and eta is the coefficient of viscosity inside that medium, and that is equal plus Fb. Fb is what? It is the buoyant force. Buoyant force will be weight of the water displaced. Weight of the water displaced or weight of the liquid displaced. That will be equal to the volume of the solid into density of the liquid. So volume of the solid is 4 by 3 pi r cube because it's a sphere, and this is density of liquid. See, density of liquid. That's equal to mg. Mg is the weight of the body. Weight of the bodies or weight of the ball is nothing but the volume of the body into density of the body. Wait, I forgot to multiply g over here because I've just written mass. Volume into density is mass. So acceleration due to gravity has should also be multiplied to get the weight. Weight is the force over here. Okay, so again here also there will be a g, and that will be the final answer. Here there will be the final answer. There will be 1 second. There will be g here, and again here also there will be g square in the numerator. So that square and this g will get cancelled. So finally it will be just g in the numerator. Okay, so let's continue. So now this is just rearrangement, nothing else here, just rearranging. You are putting v is equal to root 2 gh, and finally squaring on both the sides, you'll get the final answer. So I hope it was clear. Any doubts you have, please let me know in the comment section, and if any changes in the teaching methodology is required, just let me know. Otherwise, if you like the teaching methodology, please let me know that also, and don't forget to share it with your friends. This is very hot stuff because the test was over yesterday, and I'm posting this video today. So share it with all your friends, and subscribe to this channel also. So until we meet again, it's goodbye from me, and as I usually say, happy physicsing. Thank you.